maybe we can go a little bit deeper into the role that AI might play in accelerating technology, recognizing that regulatory almost albatross is there. Chris, you and I were talking earlier about carbon capture, and that has for many years been sort of the big thing. Like this is what's really going to create the energy transition, the emissions capture. And people say things like, well, it's not rocket science, like we should be able to do this no problem. And in fact, it's not rocket science, but it's really expensive. And if you don't have regulatory support from permitting to a price on carbon or some way to kind of at least get compensated for it, there is no incentive for folks to do it. And so it gets kind of batted around as something that's really cool and interesting, but no one's ready to sign on the bottom line yet because it's really unclear what the economic model is going to be.
Right.
So with that as a backdrop and understanding, for example, I sit on the board of Mosaic where we're an energy consumer. And we look at things like, well, carbon capture, is that part of our energy consumption reduction or emission reduction program? Well, it should be, but it's hard to see when it might fit into the strategic picture, knowing what we know today about carbon capture. So, um, and if you think about solar, wind, batteries, all of that you've talked about, what's on the kind of near-term horizon that if I'm sitting on a board, I should be really tuning into as something that if I hear this, man, we should be really thinking about this is something we ought to be, that will impact us either positively or negatively, risk or opportunity. Chris, over to you on that one.
Yeah, I'll start there. And Gretchen, I'll touch on a couple of the points you made. So just to give some framing and to zoom out and give some context, and I'll start with carbon capture because that's one that, again, it's had a lot of attention over the last 5 or so years. This is still very expensive, and this will tie to your AI comment, right? So, the storage aspect is actually relatively, now my geologist friends will get upset, but it's relatively straightforward. We can use the same types of technology, the seismic processing that we've used to identify target reservoirs. Of course, you got to drill pilot wells and understand the rock formations, but you can find locations where you can store the CO2. But that is but a small fraction of the
Mm.
overall cost of doing this. The capture piece is what is prohibitively expensive. So you need to be thinking about the sort of the range of types of emissions. And I'll touch on DAC here in a second and where maybe AI can help with this. So simply put, the cost of capturing CO2 is directly tied to the concentration at which it's emitted. So if you have a stream of 40% CO2 coming out of an exhaust source, it's relatively cost effective to capture. Natural gas fired turbines, though, emit CO2 at something like 4% concentration. So just by basic thermodynamics and science, it takes many more stages of equipment to capture the CO2. It's much more energy intensive and much more costly. So the cost of capture might be 70 or 80% the cost of an overall CCS project. So what we really need to do is make advancements on the capture side, and there's companies doing that in a variety of different ways. I sit on the board on Carbon Clean. Their approach, it's what we effectively call a process intensified solution, the same type of chemistry, but packaged in a more concentrated methodology, so you can lower the energy consumption, you can lower the space requirement, and deploy it in more spaces. MOFs are another technology. It's a different type of, you guys will be familiar with this, a different type of sorbent technology to capture CO2. But we're going to need, whether it's this one or this one, you're going to need to continue to make advancements. And that's where, ironically, I personally think AI is going to drive a lot of improvements. So it's not only going to be a consumer of electricity, and Tej, maybe I'll flip it to you after this. It's not only going to be a consumer of electricity, but if we harness AI correctly, it can help us deliver innovation to help us implement new solutions to bring down cost and lower consumption over time. Tej, what say you?
Yeah, that's a great segue actually. So I go back to sort of who we are. I mean, we're a professional services firm of around 12,000 people. We don't have a significant energy signature. We don't have significant carbon signature. It's pretty easy for us to hit our targets. If I were sort of speaking from a board perspective, if I'm a consumer of energy, I would really be taking advantage of AI to optimize energy demand. How can you use it to make your processes more efficient and lower your kilowatt hours used for your core processes? That is by far the cheapest way to address a lot of these things that are going on in the energy transition. I think there's a natural fit right there. I would love for AI to get to the point that Sam Altman often talks about of being able to invent technologies. When is AI going to help us actually create the next wave of technologies? How is it going to solve the fusion engineering problem, which is an engineering problem? It's not a physics problem. We know fusion works, but there's an engineering problem. Can AI assist us in doing that? I don't think so. Not yet. Maybe it will at some point. So we're in this sort of lag phase where AI can help us with demand and modifying and optimizing demand. It is creating additional demand on the grid. And there's a lag time to the point where it can finally help us develop the new sets of technologies that are out there. I love the reference to carbon capture, Chris. I do a lot of work in that. It's fascinating, but it's also an optimization game because sometimes the places where you're emitting carbon dioxide into the atmosphere are not the same places where you have the pore space or the geology to sequester it. So then you're talking about pipeline. And you can pipe CO2. It turns into what we call a supercritical fluid. It has components of gas and liquid at the same time, but it's highly expensive. So it is definitely an option. Pulling carbon dioxide directly from the atmosphere, the direct air capture, Chris, which I think you mentioned, that's an opportunity as well. But we need technological leaps in these spaces because they're pretty expensive. So affordability has to be a really, really considerable component of this. I would suggest that lowering demand is the most affordable way to deal with energy by far. And then it's into the suite of technologies that help if you're a consumer or a producer of energy.
Yeah, thanks, Tej. That's great, and thanks, Chris. And I would just maybe offer an example. When you talk about using AI to lower demand, that was happening already at Shell, and before AI, it was machine learning, et cetera. So we've been using technology and really big sort of data models to predict. When's the right time to be running our machines hard if power prices are lower at night, for example. It's frankly not too dissimilar from how you can optimize your own usage in your homes. You
Yeah.
have opportunities to do that. So it's the same for a business, but it's also, there's huge opportunities. We've talked about efficiency a number of times. If you are sitting on the board of a company that's a huge consumer of energy, there's plenty of opportunities to optimize, energy efficiency, whether that's the simple, getting the right lights and the right, heating and air conditioning units in, and or thinking about changing out some of the old infrastructure you have in your plants, if it's a plant, to something new that operates at much more efficient levels. So there's huge opportunities to do that, and oftentimes not terribly expensive. It pays out fairly quickly. You get to a point where it is very expensive, so there's definitely a tipping point on those sorts of things. But that is certainly, I would say, a good set of questions to ask if you're sitting on a board. How have we been looking at using AI or technology to reduce our overall energy consumption?